Okay, hi students, lesson 3, properties of limits. We are going to learn how to determine limits using algebraic properties of limits. So there are several properties here. For all of them, we're going to let b and c be real numbers. We're going to let n be a positive integer and f and g be functions. So the first one is the constant rule, and the limit of as x approaches c of k is k. And so basically, if this is my xy axis, and I had, let's say, y equals some value k, and I was looking for what the limit was as it approached c, it doesn't matter where c is. Like c could be there, c could be here. As you're approaching it, it's always going to equal that k because that's a horizontal line. So that's our constant rule. The limit of a constant is a constant. Identity rule. So for that one, we are thinking about, here's our xy axis. We are thinking about the function y equals x. So here's our function y equals x. And remember, that's your function. So y equals whatever that is. So if I chose to look at it at some c value, since y equals x, whatever x is, that's what y is. So this is going to be the point c comma c, right? And so if this was the limit as x goes to a, this is going to be the point a comma a. So my answer is going to be a. So that's the identity rule. And basically, it's because of that function y equals x. So coefficient rule. The limit as x approaches c of some real number b times a function, you can pull that real number out and it'll be the same thing as that number times the limit of the function as x approaches c. Number 4, sum or difference. If I'm taking the limit as x approaches c of two functions that are being added or subtracted, I can set those limits and look at those individually. Break those up individually. Product rule. The limit of a product is the product of the limits. Okay, so that one's nice to know. Limit of a sum is the sum of the limits. Limit of a difference is the difference of the limits. Quotient rule. So if I've got a function divided by a function, limit of a quotient is the quotient of the limits, as long as the bottom limit does not equal 0. Power rule. If the limit as x approaches c of some function taken to a power, then you can take the limit of that function to that power, and it's going to give you that same answer. Composition function rule. The limit as x approaches c of f of g of x, you can pull that f out and you can be looking at it as f of the limit as x approaches c of g of x. And the root rule. The limit as x approaches c of the nth root of f of x, you can take that nth root and of the limit as x approaches c of the function. And that's if the root on the right-hand side exists. So being skilled at reciting these rules in English will help you truly understand them. For example, the sum or difference rule can be stated as the limit of a sum is the sum of the limits. So kind of like what I was saying as we were going through there. So now example number 1, use the properties of limits to find each of the following limits. If a limit does not exist, state why. So we said that if it's a sum, that this is going to be equivalent to the sum of these limits. Limit of a sum is equivalent to the sum of the limits. So now we're going to go to f of x, which is this first one, and we're going to go to 3 from the right. So I'm coming in from the right, approaching x equals 3. Here's our x equals 3. So from the right, I get 6. And now g of x down here, I'm approaching 3 from the right. And so here's where I'd be going, moving along that way. 3 from the right is going to be 8. 6 plus 8 is 14. This one, we are going to split them up and pull the constant out in front. So I'm going to pull that constant out in front, 2 times the limit as x approaches 5 of g of x. So I've got 3 times. Now I go to f of x, and I'm approaching 5. So right here is where I land, and I get 2. Now I go to g of x. I'm approaching 5. I land here. I get 4. 6 minus 8, negative 2. Okay, this is going to be the difference. You're just going to take the difference of the first one, or well, the limit of the first one minus the limit of the second one. So I'm coming into negative 5 from the left. So that right there, coming into negative 5. Oops, I'm on the wrong one. Sorry. Negative 5 coming in from the left for f of x. So here's my negative 5. So I'm looking at where my function is. If I'm coming in from the left, I get 3. And then g of x, if I'm coming into here's my negative 5. I'm coming in from the left. It's approaching 4. So 3 minus 4, your answer, negative 1. This one is a quotient. So the limit of a quotient is the quotient of the limits. And I'm going to bring the 3 out front, divided by limit as x approaches negative 7 of g of x. So let's go up here to negative 7. I'm going to erase these. Here's my negative 7, so it's right here, and I get 5. So this is 3 times 5. Okay, negative 7 down here. Let's erase those. So here's my negative 7. That looks like 3. My answer is 5. All right. Now this is 4 times f of x times g of x. These are all getting multiplied. So since they're all getting multiplied, we can just multiply all the limits. Oops. So the limit of a constant is the constant. The limit of f of x as x approaches 3. Here's 3. Well, from the left, it's approaching 6. From the right, it's approaching 6. So that's going to be 6. And on g of x, as we approach 3, that one does not exist, right? So since this last one does not exist, because look, I'm approaching 3. It didn't say from the left or the right. It just said as you're approaching 3. Well, coming in from the left, it's 1, but coming in from the right, it's 8. So this one does not exist, and if one of them does not exist, then the whole thing does not exist. Okay, this one you can write it as the limit as x approaches negative 3 of f of x, whatever that is, we'll square it. So f of x, I'm approaching negative 3. Here's negative 3. It looks like when I approach it, I get negative 6. So this is going to be negative 6 squared, 36. This one, I can put the square root on the outside. Limit as x approaches 4 of 8 g of x. and then keep that on the outside. Bring that 8 in front of the limit, but it still has to stay underneath the root. And so now we've got the square root of 8 times something. Okay, let's look. G of x as x goes to 4. So as x goes to 4, it looks like we get 5. So that's the square root of 40, which is the square root of 4 times the square root of 10, 2 root 10. This one, limit of the sum is the sum of the limits. So we've got limit as x goes to -3 of f of x plus the limit as x goes to -3 of g of x. So we go up here and we look on f of x. When we go to -3, we get -6 plus g of x, we go to -3. For g of x, you have a vertical asymptote. And on one side, it's going to negative infinity. On the other side, it's going to positive infinity. So this one's going to be D and E. Because one part of it does not exist. So there, the whole thing does not exist. Okay, again, the limit of a quotient is the quotient of the limits. So if I'm approaching 6 here, it looks like I have 5. If I'm approaching, oops, I did it again. That was my g of x. When I approached 6, I got 5 for my g of x, and I accidentally put it in for f of x. Oops, there we go. For this one, when I approach 5, I get 2. Oh. I'm like, why doesn't it match my answer that I got when I was doing it on my own? It's because I approached 5 instead of 6. So anyway, on f of x, if I'm approaching 6, I get 0. Oh my goodness, sorry about that. Okay, and then now this one, the limit as x goes to -2. And we're going to make this f of the limit as x approaches -2 of g of x. So g of x, -2, it looks like you got -3. So this is just going to be f of -3. Notice that we don't have a limit anymore. Now we're just finding the function's value at -3. And the function's value at -3 is -6. So if it turns out like that and it works out, then you're good to go. The only time is if there's a does not exist for this limit in here, where you might have to do something a little bit differently. All right, example number 2. Find the limits if the limit as x approaches c of f of x is 3, the limit as x approaches c of g of x is -2, and the limit as x approaches c of h of x is 4. So we've got 3 different functions there. We've got f of x, g of x, and h of x. They're all approaching c. So we're going to do this just like we would, like we were doing above. I'm going to bring my 3 out times the limit as x approaches c of h of x. Bring my 2 out times the limit as x approaches c of g of x. But that whole thing is square root. So square root of 3 times, and we said that the limit for h of x was 4, and the limit for g of x was -2. So this is going to be the square root of 12 plus 4. The square root is 16. So my answer for this first one is 4. So now next one, see, it's this times this times this. So if it's multiplication, you're just doing all 3 of them. I'm going to bring the 5 in front because it's all multiplication. If it wasn't all multiplication, you might have to be careful with that, but it doesn't matter if I multiply, 2 times 3 times 7 or 3 times 2 times 7 or 7 times 3 times 2. You're going to get the same answer every single time. Okay, limit of a constant is the constant. Limit of f of x they gave us was 3. Limit of g of x was -2. So this is going to be negative 30. This whole thing to the second power, and this is going to be limit of a constant, 7, minus limit of g of x. So limit of a constant is a constant, minus limit of the g of x, so it's minus a minus 2 squared. So 7 plus 2 squared is 9 squared, 81. This one is a quotient. So we've got 2 times the limit as x approaches c of f of x plus 3 times the limit as x approaches c of h of x divided by the limit as x approaches c of h of x minus the limit as x approaches c of g of x. So this is going to give us 2 times our f of x was 3 plus 3 times our h of x is 4 divided by our h of x is 4 minus our g of x, a minus 2. So 6 plus 12 over 4 plus 2. So 18 over 6 is 3. This one is a little different. Notice that this is in parentheses, like that. So the h of x could be, you could think of it as distributing it, right? Or you could say, okay, I've got the limit as x approaches c of h of x times the quantity f of x plus 6. Okay, so, sorry. Limit as x approaches c of h of x times the limit as x approaches c of f of x plus the limit as x approaches c of 6. So you have to be careful on that one. So my h of x limit is 4 times my f of x limit is 3 plus, and then the limit of a constant is the constant. So 4 times 9, 36 for E. And now let's do F. On my notes, I just squeezed it out here, so I put too many other things on there. So this one is f of x squared. So once we put that in the numerator like that, then I can square the whole thing. But, and this one I can split up like that. And really, we could, now at this point, we could square that whole thing. So our f of x limit was 3. Limit of a constant is the constant. Our g of x was negative 2. So this is 9 times 4, divided by 4 plus 2. 9 divided by 6, 3/2. And that was for letter F. Example number 3. Given that the limit as x approaches c of f of x is 8 and the limit as x approaches c of g of x is negative 4, then find the following. And this is complicated. So the very first one, I brought the 2 out, and then I'm going to multiply it by that g of x, and then minus, this is going to be the cube root of that limit as x approaches c of f of x, plus 2, and then this is going to be squared limit, because the 2 is on the outside of the square, so I had to leave it on the outside. That one problem that we did back a little bit ago, it was on the inside. So f of x is 8. G of x is negative 4. F of x is 8. G of x is negative 4. So for this one, I get negative 64 minus 2 plus 2 times 16, 32. So negative 64 and positive 32 is negative 32, and negative 2 is negative 34. So that should be your limit for example number 3. I think I'm going to stop here.